Good evening, everybody. Welcome to night 4 of Lambda School's mini bootcamp. My name is Deandra Ryan Moss. I'm your instructor. I'm teaching you live from Bisbee, Arizona. And tonight I will be teaching the lesson entirely in puns. Not really, but there might be some punning, and I apologize in advance for that. I blame the people in Slack who started the pun chain. But anyways, let's talk a little bit about what Lambda School is, what this mini bootcamp is, and then we can jump on to the topic for tonight, which is control flow. You saw a little bit of that in last night's lecture. Speaking of which, we are on night 4, which is our second night of JavaScript. So if you are joining us for the first time, you might want to go back and check out the lesson from last night. You're also welcome to jump in, see what you can get from this lesson, and then check out the video afterwards. So yep, Lambda School, let's talk about it. So Lambda School is a 6-month computer science and web development immersive. So it is entirely online, it is full-time, and for 6 months, Monday through Friday, from dusk till dawn, not really, just normal work hours, you will be learning how to program. So how we teach Lambda School is a combination of techniques. So we do live instructions online, just like this one. We also do group work. We have solo study time, projects, Q&As, a really dynamic blend of different activities throughout the day, as well as leaving you guys homework time during the day so that you're not carrying Lambda School into your evenings as well. So that is Lambda School for you. If you do want to carry it into your evenings or only do it in your evenings, we also have a part-time option, which is a full year. It only starts twice a year, whereas the main full-time course a new one starts every single month. But that is an option we have available for those of you guys who are busy during the day and have to keep your day jobs. So we teach full stack web development in Lambda School. So front-end topics, back-end topics, frameworks, design, user experience, databases, you name it. As well, we teach some computer science and algorithm topics as well and explore a few non-web development languages like Python. So you come out of Lambda School being a really well-rounded programmer, both with all the practical skills that you need, as well as some CS foundations. As far as payment goes, we have a really cool setup, which is a deferred payment plan. So if you don't want to or can't pay your tuition up front, you do not have to. You can pay us $0 and attend Lambda School. And what we do is we take a portion of your salary over the first year or first 2 years after you get your full-time 50K or over programming job. So if you do not get a job, we do not get paid. So it is no risk for you. Well, some time and energy risk, but no financial risk for you. All the financial risk for us, because we feel really confident that you're going to come out of Lambda School and get that job that you want. So that's Lambda School for you. This boot camp is a little smaller version of it. We teach some introductory front-end topics. We saw HTML and CSS in our first 2 nights. And then for the rest of the week, for the rest of this week and for all of next week, we are going to be talking about JavaScript. So we won't be doing too much more actual web development, so much as building up the JavaScript foundations that you'll need to do both front-end and back-end development. But in some of the homework problems, we try to tie in a little bit of the web development side of it too. So that is what we're up to. Last night we did introductory JavaScript. We looked at variables, we looked at methods, we looked at properties, and at the very end, I introduced you guys to control flow. And that is entirely what tonight is all about. So control flow is this concept where, so when you normally run a JavaScript script, it executes top to bottom, more or less. We saw some subtlety, but mostly you're just going to have every line of code run in order. But sometimes you don't want that. You might want some bits of code to run sometimes, other bits of code to run other times. Sometimes you want something that might be skipped altogether in certain circumstances. You might want lines of code that actually repeat and run multiple times instead. And all of that is possible with control flow. So we briefly showed you the if-else statement last night, which is kind of your control flow 101. But tonight we're going to dive in a lot deeper on that if-else statement, and you'll see that a lot more can be accomplished with that than perhaps what met the eye at the introduction of it at the end of last night. So big deep dive into if-else tonight, and then I will introduce looping to you guys, which is another critical concept with control flow, the idea of a line of code running multiple times. So let me go ahead and share my screen and I can start teaching you guys all about JavaScript. Here we go. All right, I've got Replit open over here. As a little reminder, Replit is a sandbox environment. That means that while it's maybe not where you want to be writing production code, it's a really good place to test out smaller bits of code or to play around with things when you're just learning. So Replit makes life really easy because we can write some code. So we can write just a few lines of code here, press this run button, and it runs for us. So as a reminder, the way that Replit works is that the very last line of code, whatever that line of code resolves to, will appear over here in green. And as a little reminder, every line of code resolves to something. And resolution is not the same as any effect it causes. So for example, declaring this variable up here doesn't resolve to anything. It resolves to undefined. But that doesn't mean that this line of code doesn't do anything. So just because code resolves to something or doesn't resolve to anything doesn't mean that nothing's happening behind the scenes. I think that was a triple negative. Let me say that again. Some lines of code, even though they might have an effect, such as creating a new variable in memory, will still resolve to undefined. So that's a subtle point and one I'm going to keep coming back to because mastering that idea, I think, is one of the keys to actually becoming a really advanced, subtle JavaScript programmer. So, but back to sandbox environments. So we love sandbox environments because we can immediately see how our code works. And it gives us this nice little feedback where we can always see what the last line of code does over here. As well, if we do a console log, that will appear over here in white. So the white represents the console. As a reminder, this console is this little sidebar thing that you can make magically appear with Option Command J. And when you open the console, you can get feedback on if either messages from yourself or from other developers can appear in the console. So it's a really powerful tool for debugging during web development. In the case of Replit, we kind of just mock it out by the console log statements appearing in white. So I'll say it a third time. Anything in white over here represents the console, whereas this line in green represents the very last line of code and whatever it resolves to. So that is Replit for you. We are going to be using it for the rest of this course, both for my lectures and for the homework. So you guys definitely want to get familiar with this idea of what's in white, what's in green, what do they represent. So let's talk about some of the other things going on here. We learned last night all about different types in JavaScript. As we can see, there's a number up here that I've created. Let me create some other types for you. So I've created 3 primitive types. We have a number, a string, and a Boolean. Let me just briefly review what all 3 of those are. So numbers are exactly what they sound like, just numbers. They can be decimals, negatives, whatever you want, but they are numbers. So whenever you type out a number, you've created a JavaScript object, which is of the type number. Strings are bits of text. So anything in quotes is going to be a string. It can be a word, it can be a phrase, it can be nonsense. It could even be what appears to be a number. But keep in mind that this is still a string because it's in quotes. So it represents the string version of this number 765 rather than the actual number version. Down here we have a Boolean. There's only 2 options for Boolean values, true and false. As a reminder, if we put them in quotes, we no longer have a Boolean, we have a string. But outside of quotes, true and false are our 2 Boolean options. The other 2 data types that I introduced you to, which are quite similar, are null and undefined. So if I declare a variable and I don't set it equal to anything, and I look at what's inside of it, we can see that it's undefined. So if I just declare a variable without setting it equal to anything, that would be considered undefined. And that's one of JavaScript's way of denoting there's no information inside of this variable. I could also explicitly set it equal to something like null. And then if I check inside of it, we see it's equal to null. Once again, both undefined and null are two different ways of denoting that the data is missing. There are some subtle differences between when we would want to use one versus the other. But for now, I would just understand that they both kind of represent the same thing, which is missing data. So we could either explicitly set something equal to something like undefined, or if we just don't even set it equal to anything, it defaults to undefined. So there you have it. We have numbers, strings, booleans, null, and undefined. And as it were, they will all come into play tonight. So I hope you're feeling good about those and had a chance to practice working with all of those on the homework tonight. Let's talk about declaring variables, which I have done up here. So we have, we use the keyword const. And as a reminder, keywords are words that are built into JavaScript that mean a specific thing. So the variable names are things that we come up with and we can name them whatever we want. But const is a keyword, so it has to be spelled exactly that way every time we use it. False is also a keyword that denotes the Boolean false. So const is the keyword that we use to declare constant variables. So we use the keyword const followed by whichever variable name we choose, followed by a single equal sign for assignment, and then whatever value we want to store inside of that variable name. So now I've created, so this is the JavaScript object that we create. This is just our way of looking it up. So we can use X to look up 6. And X isn't a string, it's just a variable name. So, and once again here, this string is the object that we create. Name is just where we store it. It's our way of accessing it. Same thing down here. Since we use the keyword const, all of these are constant, which means that if we ever tried to reassign them, we would get an error. So constant is the default keyword that you should be using. Because by default, you really want your variable names to be constant. You don't want to be swapping around the values in your variable names. That's a really good way to write confusing code that's going to lead to bugs and unexpected behaviors. But sometimes you do need to change the value of something. For example, if you had an age variable for a program that was going to be running over several years, someone's age is going to be changing over that time. So you might have to update age to 11. In that case, you could use the keyword let. Let is very similar to const, except that the values that are stored inside of let can be changed. There is one other subtle difference. I will bring that up in just a little bit. But for right now, you can think about the difference as being that constant variables will stay fixed. Their value can never change, whereas let variables can change however you want. But once again, just be careful that you're using let for a very specific reason. There's a reason that they're both built in, and that's because constant variables, it turns out, are really useful for writing good code that doesn't bug out. So there's also a keyword called var. As mentioned, we mostly just don't use var anymore. It's a little bit outdated, so I won't even go over that. I want you guys to be sticking to const and let for the remainder of this course. So let me talk about a couple other cool things that we can do, especially with numbers. So we can, first of all, if we wanted to increment age in a little bit of a simpler way, we could use our plus plus operator. We talked a lot last night about this idea of code resolution, and as a reminder, this line of code is still resolved to 10, but if we look inside of age on the next line, it's gone up to 11. So the plus plus increments the value of whatever variable comes before it, but it doesn't go into effect until the next line of code. We also, with the Q&A, saw that there's a different version where we put the pluses up front. I wouldn't worry about that one for now unless you're interested in messing with it on your own. Just stick with plus plus. So we saw that there's this plus plus operator and the related minus minus operator, which does the opposite. It decrements this variable. We also saw that we can compare numbers. So there are things called comparison operators. And if we compare two variables, two numbers, we don't just have to compare numbers, by the way, but that's a good place to start. So if we compare two numbers, we see that these two numbers are combined together to output a Boolean. So this comparison will resolve to a Boolean. We can also do greater than or equals to, greater than, etc. One thing I mentioned very briefly last night is that we can compare with the triple equal sign. So the triple equal sign says that two things are equal. I'm going to talk a little bit more about that later, as well as the double equal sign, which is another comparison operator that's a little more confusing to work with. So little preview of what's to come, a little more discussion on triple and double equals. So that is pretty much everything I wanted to go over. Oh, yes, sorry, one more, which is the not operator. If we do not on a Boolean, we get the opposite. So if we do not on a false variable, it's going to resolve to true. If we change this to true, it will resolve to false. As a reminder, this operator, unlike plus plus, doesn't change the value of likes JavaScript. It just creates a new Boolean. So we're not actually changing the value of this variable. We're just using the value to create a new Boolean. So the not operator is going to come into play a lot tonight. So we will see a lot more of that. The next thing I want to remind you of is the if-else statement, because we're going to see a ton of this tonight. So let me go ahead and throw an if-else statement down here. So we say if likes JavaScript, if you don't like JavaScript, probably like, when is this class over? All right. So there we go, an if-else statement. Drag this over a little more. So an if-else statement is our way of telling the code behave one way sometimes and another way other times. So we essentially have two options for what the code might do. And one will always execute, but never both. And they determine which will execute using a Boolean. So to remind you of the syntax of if-else statements, we start with the keyword if. In the parentheses, we have some sort of condition. This is what determines which one of these will execute. Then following that, we have two curly brackets. Inside of this curly bracket is the if block. And as a reminder, even though I only have one line of code here, I could put as many lines of code as I wanted in the if block. And everything inside the if block, inside the curly brackets, will run if this condition is true. So right now, likes JavaScript is set to true. And I'm still misspelling it. Didn't learn my lesson last night. So we log out control flow is interesting. We can see that log statement appear in white over here. The else statement does not execute. Because this resolved to true, the else statement is skipped altogether. So line 9 never runs. But if we flip it, the opposite will happen. Line 7 is skipped, but the else block is run. So we have if and else, two different options depending on what's in here. As another reminder, we can, like I've shown here, we can do a variable that resolves to a Boolean. We can do some sort of comparison that resolves to a Boolean. We could also just do a Boolean itself in here. So what we're really looking for now at least, in this condition statement is something that resolves to a Boolean. So there you have it, a little review of the if-else statement. Seems maybe pretty simple, but there's a lot of complexity that we're about to see tonight. So there is a little review of everything we went over, maybe not everything, but a lot of what we went over last night. And you guys had some opportunity to practice that on the homework as well. So let's go ahead and dive into some different topics. The first thing I want to talk about is something called scope. And in order to do that, I'm going to actually just simplify this down to an if statement. So get rid of that. So once again, another little reminder is we can have if statements on their own. We might want a case where there's some optional bit of code that runs, but no alternative. If the alternative is that nothing happens, then there's no need to write an else. We can just have an if on its own. So we see right now that the if block never runs. And if we change this to true, now our if block runs. So I mentioned that the inside of the parentheses is something called the if block. And something interesting about this block is that it has something called scope. And so scope it's an idea we've vaguely touched on, but without really using that word. So scope, it's essentially a way of thinking about where in the code are we. And if we're at the top level, we're in the global scope. So up here we have global scope. And think of this as like public information. Everything that happens in the global scope is available everywhere. So all these variables have been created in the global scope. That means that anywhere we want to access them, as long as it's below where we declare them, they're available to us. As well, we saw some global objects last night, like console and math, that are just automatically available globally. So the global scope is the most general sense of scope. And it's kind of almost trivial to even talk about because we're just saying, okay, these variables are accessible wherever we need them. But it becomes important to talk about scope when we get into block scope, like this if block. So the if block has its own scope as well. And this works a little different than the global scope. Whereas all these guys are public, you could think of everything in the if block as being kind of private. So let me go ahead and create a new variable here. So we have x. Let's create a y. Let's say we want to combine these. So let's go ahead and create something called z, which is x plus y. All right, and I'm gonna change this around. So if addition, let's go ahead and console log z. Okay, so within this if block scope, everything, it can reach outside of itself. So everything available in the global scope is going to be accessible in here. So we could, console log, well, first of all, we can see that we're even using two of the variables from the global scope. So let's go ahead and run this. We see that it works as expected. These two variables from the global scope were added together and stored inside of z, and then z was logged. So that's all as we'd expect. These guys are accessible. But when we declare a variable inside of a block using let, we've specifically declared it in the if block scope. So that means that this variable only exists as long as the scope is in effect. In short, if I try to console log z outside of the if block, you get a reference error. So this, I mentioned earlier that there's one other cool subtle thing about let, and this is it. So the rule is that if we declare a variable using let inside of the non-global scope, it will only exist as long as the scope is in effect. That's only true with let. So if I console log z now, we're going to be fine because, wait, what have I done? Does const have scope block? My gosh, I feel like JavaScript is not behaving as I expected. Well, apparently in if statements, const also has scope blocking. So my bad. I misspoke on that account. So just kidding. Both let and const have this scope thing. So, so yeah, because we declared this variable inside here, it's not accessible outside. What's cool is if we want to make z accessible, we can always just declare it outside and then assign it inside the block. And then down here, z becomes accessible again. So that is allowed, kind of hacky. Wouldn't recommend it if this is built into JavaScript for a reason. Now, I feel like we're falling a little bit down the scope rabbit hole. And as far as this let const subtlety, you don't have to worry about it too much. It's something that's good to be aware of so that you're not wondering, where is my Z? Like, why does Z not exist? I defined it up here. But the bigger takeaway is just to think about that whenever we create this type of block scope, like this if block, that there are some new rules that apply. And as a reminder, we can reach out and grab things from the global scope, but we cannot pass things back out. So anything inside of the if statement stays in the if statement unless, we declare the variable outside or if we're doing something like console logging. So, and yes, as someone mentioned on the Slack channel, var is something that we can use inside of the block. So if we declare the scope subtlety does not exist for var. So it's kind of a newer feature. As I mentioned, up until about 3 or 4 years ago, var was our way of declaring keywords. But they changed this for a reason, which is that the developers of JavaScript determined that you will be a better coder if your variables inside your if block stay in your if block. So it was an intentional design choice. There might be some scenarios where it's better to just use a var, but I would challenge you to stick with const and let, even though there are some subtle rules that are involved with them, but they actually will make you a better programmer in the end. So scope. We will be coming back to scope a lot over next week. So I wanted to introduce this topic tonight. But let's go ahead and move on from scope so we can talk about some other cool things we can do with if statements. So I want to talk a little bit about comparison operators next. So I already introduced those last night and already reviewed them today. And comparison operators are just our way of comparing values. So we saw that we can compare X and Y and use that as a way to trigger our if statement. If I can figure out caps lock on. Okay. So we can use comparison operators to trigger our if-else statement. So you should at this point be at least mostly familiar with less than, greater than equals, and less than equals. So there you go. I do want to talk about the triple equals in a little more detail. So as a reminder, the triple equals checks to see if two values are equal. So those would not be equal. These would be considered equal. But the triple equals is not just limited to comparing numbers. We can compare any JavaScript objects using it. So if I compare 6 and the number 6 and the string 6, we'll see that those are not considered equal. So that is the equal sign. We can compare strings. If I made both of these the same string, now we would get true. And it's a really common mistake for new developers to write this and not understand why their code isn't working. It'll just take a little practice to start to think about the triple equals as comparison. So single equals is always for variable assignment. Triple equals is for comparison. There is also a double equals, but I would warn you as a new developer to stay away from the double equals because it's a bit more subtle. So notice that now X and Y are considered to be equal. When I run this, I get if. That's because they're not exactly the same, but they're kind of the same. If I were to compare undefined and null, we would also get if. But these are not truly the same. They're just similar. So you have to be careful with the double equals because if you don't fully understand the rules of it, strange things will happen. So I wanted to make you aware of it, but for now, stick with the triple equals because that will tell you if they are precisely equal or not, which is a really good place to start. I also wanted to show you how to use the not operator with equal sign. So not double equals, this would be the opposite of triple equals. So this would now be considered true because it is true that these are not equal. And this is where it starts to get a little tough to keep track of what we're working with because these aren't equal, but because I use the not equal sign, we get true because it is true that these are not equal to each other. As well, if I did, some string and some other different string, we would get true because these are not equal to each other. So the not equal operator can be nice. It's kind of weird with the if-else statement to do a not equals, because you're basically, you know, why wouldn't you just do an equal sign and swap what's in the if and else? But there are times when you just have an if on by yourself, and you might say, you know, if x is not equal to 7, then we want to do something, say. So now whenever is not equal to 7, we get this statement logged. So you'll often see these not statements when you have an if just by itself. So then if we change this to 7, nothing runs. Cool. So those are the comparison operators I wanted to introduce you guys to. And once again, they really deal with this topic of code resolution, because we're taking this whole line of code, everything in the parentheses here, and it resolves to a Boolean. So even though this involves a variable, a number, it could involve a string, it could involve anything, this whole thing will resolve to a Boolean. And that's what happens when you use a comparison operator. You take other data types and turn them into Booleans. So the next thing I want to talk about is truthiness and falsiness. So I said that right. Truthiness and falsiness. I think I spelled those right, hopefully. So I've been vaguely mentioning that what we have in our if condition doesn't have to be a Boolean. And that's because of truthiness and falsiness. So let me just comment out my if statement. I'll just get rid of it, honestly, so that we can really talk about this. So every single object in JavaScript, every single variable you can create has a truthy or a falsy value. So we'll do condition truthy, else. So this is a way of falsy. I think falsy should have an E. Spelling of made up words like falsy. Not sure how to do it. So every single variable will either resolve to true or false when you put it in an if statement. So obviously, if our condition is a Boolean, like true, true is going to be truthy because it's true. And false is going to be falsy. So those are the low-hanging fruit. Those are pretty obvious. But let's move out of Booleans. Let's move into numbers. So it looks like positive whole numbers are truthy, even really big ones. It looks like decimals are truthy. What about negative numbers? Also truthy. So you might be starting to think that all numbers are truthy, and that's almost the case. There is one number that is falsy, and that is 0. So all numbers except 0. 0 is falsy. All right, let's look at strings. So the string true is truthy. The string false is also truthy. Some nonsense is truthy. And once again, it's looking like almost all strings are truthy, but there's one exception, and that is the blank string. So if you just do two quotes together, you create an empty string. The empty string is falsy. So all strings with content. The empty string. So any string with content, any number except 0 is going to resolve to, in an if statement, to true or false. Or sorry, to true. Whereas 0 and the empty string will resolve to false. So we've looked at most of our primitive data types, but let's look at our friends null and undefined. So here are two examples of things that are falsy, null and undefined. So let's see if we see a pattern up here, because this is kind of a weird concept, right? So truthiness is all numbers except 0 are truthy, all strings with content are truthy. We see down here that 0, the empty string, null, and undefined are all falsy. So maybe you guys are starting to see the pattern, which is that pretty much everything in JavaScript is truthy unless there's some sort of indication that the content is missing, the data is missing. So 0, which represents no numbers, the empty string, which is no text, null, and undefined, which just means a value missing altogether, will all be falsy. And this is a little bit weird, right? When I first was introduced to this concept, I thought it was really stupid and wouldn't ever be useful, but it turns out it's useful a lot. And the context that I most often see it in is if I'm curious if the data exists or not. So let's say, you know, we had some information about this character, but her address is missing. Her address is set to null. So we might say something like, if address, or if no address, so that's if the address is missing, console.log error missing address. So this is really useful when we have to check if information we're expecting to have might be missing. So if the address were null or if the address were a blank string, then we could check and see if it was missing or not. Of course, this isn't perfect because if the address were just the number 6, which is obviously not a full address, we wouldn't trigger this missing address error. So, so it's not a perfect system, but I found it extremely useful for, you know, cases where we want to check and see if a piece of data is missing, whether it's to error out or to, you know, have some sort of default that we put in there. So, you know, maybe if name is missing, so if no name, we'll do let. Then maybe we want to set name equal to John Doe or something like that. So now we can see that because the name is missing, we will auto set it to John Doe. So here are a couple little examples of where truthiness and falsiness actually become really useful. So there you go. All right, let's talk about some logical operators. So we've seen comparison operators, which are ways of comparing two values to create a Boolean. Logical operators are similar, except they're a way of combining logic together. So let's start with, let's just introduce them. So the first one is and. So and is a way of combining two Booleans. So let's say we are, I'm trying to think of an example I didn't use on your homework. Let's say that we would like to go for a walk. So we're interested on if it's raining. And we're also interested on if we have gym shoes. So in order to go for a walk, we need to have gym shoes and it needs to not be raining. So we would say that, actually, sorry, let me change this to good weather. So to go for a walk, we want the weather to be good and we want to have gym shoes. So we want to make sure both of these conditions are true in order to go for this walk. So we could create a new Boolean and say good weather and has gym shoes. So what we're saying is that by using this new operator called and, which is represented by the double and sign, so two ampersands, we're saying that both of these have to be true. Both of these conditions have to be met in order for this to be true. So if we do can walk, that's equal to true. So, so yes, right now can walk is equal to true because both of these conditions are met. But let's say that one of these were false. So if my gym shoes have been eaten by the dog, I can no longer go for a walk. if we swap that and say, okay, I have my gym shoes, but the weather sucks right now, can walk is still false. And of course, if both of those aren't true, then it's still false. So the and operator is a little touchy. It requires both conditions to be met. So it's a way of combining two Booleans to create a new Boolean. So and will only be true if we have a true and a true. Once you introduce at least one false into the mix, this whole thing becomes false. So that is the and operator for you. Let's talk about or now. So if we have, let's say we have an umbrella. So now either the weather has to be good or we have an umbrella, because even if it's raining and we have the umbrella, we can still go for a walk. So let's update this to has umbrella. So now instead of requiring both conditions to be true, we just require one or the other. So notice that, oops, sorry, let me actually change this to or, my bad. So the or is two pipes next to each other. So these aren't L's, they are the pipe symbol. You can find that on your keyboard right next to the slash, or right above the slash. So two pipes together equal or. So now one or the other or both. So if the weather is good, we don't care that we don't have an umbrella. If the weather is bad, but we have an umbrella, that's okay too. We'll still go for the walk. If it turns out that the weather is good and we own an umbrella, then it doesn't really matter. We probably won't bring our umbrella, but we can still go for a walk. However, if both conditions are false, now we can't go for our walk anymore. So or is less choosy than and. It only requires one of the conditions to be true in order for the entire thing to resolve to true. So both can be true, the first can be true, the second can be true, but if they're both false, then this or statement will resolve to false. And as you might imagine, these statements are incredibly useful for if-else statements. So if I wanted to instead console log something about walking, I could do if good weather or has umbrella, and I console log go for a walk. And notice that nothing is logged because they're both set equal to false. So the big logical operators here are going to be the not operator that we saw at the beginning, the and the or. And they take some getting used to if you're not used to working with formal logic, but where they really get challenging is when you start to combine them. So let's change this to is raining again. So now it's a little confusing because we're curious about if it's not raining, right? Because if it's not raining, or if we have an umbrella, then we can go for a walk. So notice that now this has gone a little weirder, right? So let's say these are both equal to false. We can still go for a walk. Let's break down why that is. So now is raining is equal to false. We know that means that the weather is good. Have an umbrella is false, but we don't care because the weather's good. But let's say that this were true. Now our statement, our if statement, never triggers. And that's because we know that it is raining and we don't have an umbrella, so we can't go for a walk. So I want to say again, these things are tricky if you're not used to working with formal logic. You really want to break it down one at a time. So you would say, okay, what does this resolve to? Okay, is raining is true, but we have a not, which means this is false. So we could say, okay, that's false. And we have an or, and has umbrella is also false. We know that false and false equals false. So you're going to have a lot of practice with this type of thing on the homework, and it does take practice. And these things can get pretty advanced. And sometimes you might mix up the parentheses. So now this might not make sense as well with the example, but I just changed it here. So now that these are in parentheses, we would do the or statement first and then switch it. So we would first say, okay, that is raining is true. So true or has umbrella is false. So we know that true or false is going to be true, but then we have a not statement on the outside. So this is true, but when we put the not statement on it, it all becomes false. So there's some fun with logical operators. You have a lot of opportunity to practice those tonight in the homework. There's one more thing I want to show you with this not operator that's kind of cool. And it ties into this idea of truthy. So as we know, let's go ahead and get rid of all of our if not or if else not stuff and do if condition. So if we set condition equal to a string, we know that because the string has content, that condition is truthy, so our if statement will run. But of course, condition isn't a Boolean, it's a string. But let's say we wanted to convert condition to a Boolean. Well, if we ever did not condition, this is going to become the opposite of whatever this is. So because this is truthy, this actually will become false. And once again, it's not that this becomes falsy. When we use the not operator on a truthy statement, it just becomes false. It actually turns it into a Boolean. So you can use the not statement to turn any JavaScript object into a Boolean. It just flips it over to the opposite of what it was. So if condition is now false. If I want to do a double not, this is really useful. So the double not is kind of weird. With a Boolean, it just turns it into itself. But we can use the double not to turn this variable into, if it's truthy, it becomes true. So now we've turned a truthy variable into just the Boolean true. So that's kind of a nice thing to be aware of, is that we can use this not statement or this double not statement to actually turn a non-Boolean into a Boolean. So this actually becomes useful in a lot of contexts. So I wanted to just introduce you to this little trick. So what this does is it turns something that's truthy into true, which is a Boolean. And it turns something that's falsy, which is, once again, not necessarily a Boolean, into false. So this is kind of a shortcut to turning any variable into either true or false. So there's the double not for you guys. Okay, I want to shift focus a little bit over to something called the else if statement. And this was, I believe, brought up in the questions last night, and I kind of shrugged it off because I said I'd show it to you today. So as you might have noticed, the if else statement is great if we only have two options. So we have one thing that executes or another, but let's say that we have more options. So if we had something called direction, and we knew this was going to be set to east, west, north, or south, we couldn't do a subtle if-else statement. We could only have two options. But let's do an else-if statement to add in more options. So if, let's say that we are facing east. So if direction equals, once again, I'm using triple equals, we might console log go straight. So because we're facing east, if the direction we're headed is east, then we want to go straight. Now let's cover the case where it is equal to west. So we would do else if, and we can do another condition here. So we do else if direction is equal to, let's do south. See if I can get this right. So console log, now we want to turn right. So let's break down what we did here. Instead of an else, which is just a default statement, we now have added in a second condition. So we're saying, okay, let's check this first condition. If that isn't true, let's move on and check our second condition. Now let's do another else if statement. So if not, maybe direction is equal to west, in which case we would need to turn around. And then we can do an else statement, because we know that if we could do another else if we wanted, but there's really no reason, because if it's not east, it's not south, it's not west, we know it has to be north. So we could console log go left. So there you have it. Now we have something that's dynamic and can deal with 4 different options. And if we wanted to, we could even do else if north and then have our else statement saying that our direction is invalid. So let's look at the syntax here. The if statement looks exactly the way we're used to our if statement looking. We have the keyword if followed by a condition, followed by an if block, and there's some information in that. Then we see the keyword else as usual, but we follow it with another if and another condition. So if this one is not met, it will check the next one. If this one is not met, it'll check the next one. And then finally, we can default to else. So we can have ifs by themselves. We can have ifs with if elses. We can have ifs, if elses, and elses. We can combine these in a lot of different ways to have different subtle behaviors of our code. So there's and this thing, as a reminder, is called else if. And sometimes it's called elif, but I don't like that. So I call it else if. So yeah, that's else if. So if else, if we swap those, it's just the if and the else. But else if statements involve some sort of other condition apart from the original if one. So, and of course we can combine all these ideas. We could have an or statement in here. We could have a truthy value in there. We could have an and statement in there, etc. So the if else is pretty simple, but it can get complex really quickly when we start to throw in comparisons and conditionals and else ifs, and it takes quite a bit of practice to master this, even though it is a relatively basic concept. Even the simple stuff in JavaScript goes pretty deep, but that's one of the things that makes JavaScript so advanced. All right, so let's see. What else are we doing? Yes, we are doing, sorry, I got distracted by, there's a comment in Slack about that maybe my directions aren't right. So if you're going east, so I'm assuming that we're heading east. So if we're heading east, but we want to head south, I think that's where the confusion arises. So we think about the direction is where we want to go. So we want to go, but we're already going east. Does it make sense? I don't know. I'm really bad at lefts and rights. I shouldn't admit that, but I totally am. Total tangent though. Okay. We have to make sure that's squared away. You'll never learn JavaScript if we're not clear on our cardinal directions. Okay, let me do the for loop now. So this is the next kind of a totally different topic that we'll close with, is the for loop. So let me show you where you would want to use a for loop. So let's say I'm going to console log a countdown from 3 down to 0. So console log, oops, can't do lefts and rights, can't count. All my basic logic skills are broken. This is totally a real thing though. The more you get into programming, the more you'll find that your ability to do really basic, simple things kind of deteriorates. So just a warning, you have been warned. Okay, so I want to count down from 3 down to 0. So I write out 4 different console logs, I run it, it works. And that's all fine and good, except that I've just written almost exactly the same line of code 4 times in a row. And we do not like repeating ourselves. There is this concept that I'm going to bring up from this point on again and again called dry programming. And that stands for don't repeat yourself. So whenever you're repeating yourself, that means you are writing bad code. Bad code uses repetition. Good code uses clever things that we can use to avoid repetition. And in this case, we would want a for loop. So a for loop is called for whenever we have repetition. And it doesn't have to be precise because each of these lines of code is slightly different. But when you have something similar happening again and again, we want a for loop. Of course, if I also just console logged the word yam 6 times, then yeah, this is another example where I'm literally repeating myself really bad. So another example where we could use a for loop. So let's start with the yam example. Let's create a loop that will allow us to log yam 6 times, because, you know, when would you not want to log yam 6 times? So let me write out a for loop for you, and then I will explain what is actually going on inside of it. So voila, I've only literally written my console log once, but it logs 6 times as I wanted. Okay, so I know I just totally typed that out with some expert coding wizardry, but let's talk about what is going on here. So we start with a keyword called for. That is our way of saying we're about to do a for loop. And then inside this, kind of like our if condition, we have actually 3 different for loop conditions we have to set up. So the first one, and they're not really conditions, they're more like guidelines. So the first one is, or instructions on how to loop. Guidelines sounds like maybe the code will break the rules sometimes, which would be really bad. That's probably, if your for loop doesn't listen to the instructions in the parentheses, either you've coded something wrong or it's the beginning of the robot apocalypse. So keep an eye out for that. Okay, so the first thing that we put in the for loop is we actually have to declare a counter of some sort. We need some way of keeping track of where we are in the loop. And we always want to use let, because this counter is going to be incrementing or decrementing or changing in some way. By default, you would always call your counter I. It doesn't need to be I. You could even call your counter yam if you wanted. If I change my counter to yam, my loop still runs, but my fellow programmers might be a little confused. So maybe stick with I. So we, by default, are going to start I at 0. There's this thing in computer science where we always start counting at 0. It's kind of annoying. It's kind of great. You'll see more of it. So we start I at 0 by default. And then we say, okay, run this as long as I is less than 6. So subtle point is that because we're starting at 0 and we're ending before we hit 6, that means we get 6 times. So this is our 0th time, our 1st, 2nd, 3rd, 4th, 5th. So it still adds up to 6 because we started 0. Yay, 0 indexing. So I is less than 6. It will run as long as I is less than 6. And then every single time we loop, we do this thing to I. So in this case, we just increment it by 1. So what happens is everything inside of our for block, and yes, we have some more blocks, will run. So we'll start with I equals 0. This will run. So we have I equals 0. This line executes. First yam. Then we increment it. Now I is equal to 1. This runs yam. Well, first of all, we check this. Okay, so we're not less than 6. Then we increment. So now I is equal to 2. This runs yam. That's still not true. I should have done less than 6. This is getting tedious. We increment it again, yam. We check. We increment it again, we yam. We check. We increment it again, we yam. I did that out of order because we increment it and then we check this last time, and it is now no longer less than 6, so we stop. We no longer console log yams. So that is kind of a little bit of a insider's look at what is actually happening in a for loop. In short, you can just say, okay, this is going to execute everything in the brackets 6 times. If we wanted it to be 10, we could do that. If we wanted it to be 1, we could do that. If we wanted it to never run, we could do that, but that's kind of useless. Or that, because notice that if we're starting at 0 and we're incrementing, I is always going to be less than -12. So yeah. So we have to keep an eye out for what's in here, because otherwise our loop might never run. Or if we did something like if I is equal to -12, or sorry, not equal, greater than -12, we just got an infinite loop. Why was that? Let's think about our conditions. So we started at 0, we increment every time, and we keep going as long as I is greater than -12. Well, if we start at 0 and we're increasing I, it's always going to be greater than -12. So we never reach a point where we're told to stop. Luckily, Replit has a little catch built in where it won't let you blow up your computer. So that's good, but you want to try and avoid infinite loops. So be careful about what your conditions are, because if you set them up wrong, you'll probably get an infinite loop. But it's kind of a rite of passage to get your first infinite loop. So, okay, so there's our YAM example. Let me show you this counting one. So I'll start by just counting up from 0 to 10. So how would we console log a number, right? Because we could start it at 0, but then we just console log 0 10 or 11 times, 10 times. But that's where I comes in handy. So whenever we want something that's changing numerically, we can actually use I. So I exists inside of our for block. I does not exist, another example of scope, down here. But as long as we're inside of our for block, I exists. So we can use it to count up or to count down, like that first example. So if I want to count down from 3, I would have to start at 3. I would have to say as long as I is greater than or equal to 0. And now I want to do I minus minus. So there you go. So 3, 2, 1, 0. So as we see here, this doesn't have to be plus plus. We don't have to start at 0. Often we do start at 0, and often we do use plus plus. But if we're trying to go backwards, we could do this. Another example is, what if we wanted to skip some things? So we could actually do I equals I minus 2. So now, instead of using the minus minus, we're saying let I equal I minus 2. And now we decrease in increments of 2. As well, if we wanted to do the opposite, go up to 10, we could do I plus 2. And there is a little shortcut here where we can actually do something called plus equals, which accomplishes the same thing. So plus equals minus equals, also something you can use. So that is looping for you. We've just seen a pretty simple loop. But it's basically a way that we repeat lines of code, sometimes using a variable value like this I to change our behavior. Sometimes if we just want to print YAM a bunch of times, we don't even have to work with I. We can just write console log YAM. So there you go. That's loops for you. And yeah, so let's talk a little bit about the homework tonight, and then I will open up the floor to questions. And I already see some questions floating around Slack that I can answer in just a moment. So once again, for the homework tonight, you will have 2 assignments. One is another kind of reading code assignment. It has all to do with Booleans. So you'll have to look at a bunch of different true and truthy statements and figure out what they resolve to. So you'll have some of that logic practice. That's me trying to drill you on these things so that they just become second nature. So the more you practice them, the more they'll just be second nature when you're actually writing code. The next assignment will be some actual code writing. So you'll have a chance to do a little bit with the if else, and mostly just to write a ton of loops. So you'll have a lot of fun messing around with these conditions to make your loops act just in the right way. So let me now open the floor to questions. I see that we have a question about infinite loops breaking your computer. Generally speaking, no. Luckily, we have a lot of built-in catches. Of course, in Replit, it'll catch it for you. In the console, it'll catch it for you. So pretty much any way you're going to run your JavaScript, it's not going to crash your computer. It's just going to at some point say, hey, Stack Overflow, we think that you're doing something crazy. Maybe you should stop it. All right. So yeah, don't worry. Don't be too scared working with loops. It's not going to break your computer unless you're doing something really crazy. Okay, so we had a question about looping to calculate a Riemann sum. So yeah, that could be a potential use case. So if people out there don't know what a Riemann sum is, it's basically, it's part of integral calculus. So if you're doing some fun integral calculus out there, you could use a loop to accomplish that. There are also, I don't know what if you're just curious or you have a specific use case, for doing more advanced math things, there actually are some really cool math-related languages like Mathematica out there that have things like that just completely built in. But it could be a fun little challenging project to try and write a script that calculates an integral doing that. Actually, sorry, you brought up calculus and now I'm on a tangent. But when I was in coding bootcamp, my first project was like creating this integral visualizer. So I actually built Riemann sums. And that was really fun for me because I'm a complete nerd, but let's talk about JavaScript again. All right, I see someone typing. Let's wait a minute for any more questions to come in. Okay, great question. So there's this, actually I'm super excited you asked this question. So there's this question about, I wrote out I equals I plus 2 instead of I plus 2. So if I had just done I plus 2 here, I would never increment. Because what we're doing is, let's talk about the difference between these two lines of code. So in this line of code, actually I'm going to put them in the opposite order. So in this line of code, I add these together. I add whatever the value of I is to 2, and it will resolve to the result, but then nothing happens with it. So this will resolve to something being added together, but it's not stored anywhere. So this line of code essentially on its own doesn't do anything. It adds some things together, but then they turn to smoke. So we need to actually change the value of I in order for our loop to work. This does not change the value of I. It just uses I to create a new number. So over here, we add them together and then we take that new value and store it back into I. So this won't change I, this will, because we're taking a new number and storing it into I. And as a reminder, I++ is kind of a special operator because it actually works on I itself. Behind the scenes, it stores a new value into I. So I++ is exactly the same thing as saying I equals I plus 1. So these two lines of code are the same. It just turns out that we do this so often that we just came up with a shorthand way of doing it. All right, any other questions before I let you guys work on your homework? All right, I see all is quiet in Slack, so we will call it a night for the lecture. All right, thanks so much for sticking with me tonight. We learned all about scope and a bajillion different things we can do with if statements and logical conditionals and fun things like that. And then finally, we closed out the lecture with the for loop, which is a pretty big staple of programming. We like to be able to run lines of code multiple times without copying and pasting. So you'll have some practice tonight, both with those logical operators and with looping. So have fun with that. As always, look in your group channels for the homework. It will be posted there. If you're not in a group or if you're working on this lecture not in real time, you probably want to join the after hours group. That's somewhere where the homework is posted so that people can work on it on their own time. And if you haven't entered in your information to the Slack bot, definitely do that. So sorry about all the confusion about groups and homeworks. We're trying to get you guys all situated, but I think most of you know where to go to get the homework. But all right, so that is it for this week. No class tomorrow, no class this weekend. I definitely encourage you to take a break. I know it's really tempting, especially because I just crammed all this information at you to feel like you need to study and review and practice. But my experience time and time again is that if you step away from it from a couple days, you'll get more benefit out of that than studying or cramming. So enjoy your weekends, and I will see you guys on Monday, and we will talk about functions then. So oh yes, and Monday is a holiday. I will be teaching live as usual, but we don't expect you to be here. So if you're not able to make it here, you can just watch that lecture on your own time. I know that doesn't leave you a lot of time to actually catch up with it, but so hopefully you guys can watch it. But yeah, that is the deal with Memorial Day. All right. So have a great night and good luck with the homework. Bye, guys.